and welcome to this session on containerization using Docker. Today, we're diving deep into the world of Docker, and by the end of this video, you'll have a comprehensive understanding of why Docker has become a game changer in modern application development and deployment. First, we'll start with understanding application architecture. This foundation is crucial because it helps us appreciate how Docker fits into the larger ecosystem of software development. Next, we'll tackle what is Docker, and why should you care. We'll break down Docker in simple terms and explore the real-world challenges it solves. From there, we'll take a step back in history and look at virtualization versus containerization, the evolution. This section will help you understand how containerization emerged as a more efficient and flexible alternative to traditional virtualization methods. Then, we'll dive into understanding Docker components. Here, we'll explore the building blocks of Docker, from images to containers, networks to volumes, and how they all work together. We'll move on to how Docker works, building, deploying, and running containers. This is where the magic happens, and you'll see Docker in action, as we walk through the entire lifecycle of a containerized application. Once you're comfortable with the basics, we'll discuss the power of Docker in CI/CD pipelines. You'll discover how Docker streamlines continuous integration and continuous deployment processes, making development and deployment faster, more reliable, and more consistent. We'll then cover the advantages of using Docker. This section will highlight the numerous benefits Docker offers, such as scalability, portability, and resource efficiency, making it clear why Docker is so widely adopted. Next, we'll discuss some important concepts with Docker. We'll clarify essential terms and ideas that you need to know to become proficient with Docker. After that, we'll walk through some common Docker commands. This will be a quick hands-on guide to the essential commands you'll use daily, so you can get up and running with Docker immediately. Finally, we'll wrap it all up with real-world use cases and conclusion. You'll see how Docker is being used across different industries and how you can start implementing it in your projects today. So, stick around as we unravel the Docker journey together, and by the end of this video, you'll have a solid grasp of how Docker can transform the way you develop, deploy, and scale your applications. To understand why Docker is such a big deal, it's essential first to understand the evolution from monolithic to microservice architectures. Imagine you have an e-commerce application that handles everything: product listings, payments, user accounts, and more, all packed into one massive tightly coupled codebase. This is a monolithic architecture. The downside of this is, if one part of the application crashes, you must shut down the entire app to fix it. In contrast, microservices break down this monolith into smaller, independent services, each handling a specific function like payments, inventory, or user authentication. This loose coupling makes it easier to maintain and update. But it has its own challenges. Managing multiple servers and databases becomes more complex and costly. And this is where Docker comes into play. So, what is Docker, and why should you care? Docker is an open-source platform designed to make it easier to create, deploy, and run applications by using containers. It essentially helps us package applications and all their dependencies into containers, ensuring they run consistently across any environment. Docker solves the problem of "it works on my machine" by providing an isolated environment that runs everywhere, whether it's your laptop, a cloud server, or a data center. Let's have a quick look at the evolution of how we manage and deploy applications in computing environments. Before Docker, virtualization was the go-to solution for running multiple applications on the same hardware. Virtualization creates virtual machines, VMs, each with its own guest operating system. However, running multiple VMs can be resource-heavy, leading to security risks, slow performance and management complexity. Docker's containerization approach is much lighter. Instead of virtualizing the hardware, it virtualizes the OS, allowing multiple containers to run on the same host OS without the overhead of full-blown VMs. Each container holds everything needed to run the application: code, libraries, dependencies, and even configuration files. Key advantages of containerization. Cost efficiency. Docker significantly reduces deployment time, with image deployment taking only seconds. Scalability. Easily scale containers up or down depending on demand. Stable environment. Docker containers create isolated and predictable environments. Portability. Containers share the host OS, making them faster and less resource intensive. To get a full picture of how Docker works, it's crucial to understand its main components. 1. Docker image. A Docker image is like a template or blueprint containing everything required to run an application: code, libraries, dependencies. When you create a container, it's instantiated from an image. 2. Docker container. This is the running instance of a Docker image. Think of it as a lightweight, standalone executable package that includes everything needed to run your software. 3. Docker engine. The core part of Docker, the Docker engine, is the software that runs and manages containers on the host machine. 4. Docker registry, a storage and distribution system for Docker images. Docker Hub is the default public registry, where you can pull and push images. You can also set up private registries for internal use. 5. Docker daemon, the background service running on the host OS that manages building, running, and distributing containers. 6. Docker client, the command line tool you use to interact with the Docker daemon. How Docker works: building, deploying, and running containers. 1. Building an image. You start with a Dockerfile, a text file that contains a series of instructions on how to build your Docker image. The Dockerfile specifies the base image, for example, Ubuntu, the application code, dependencies, and any other setup instructions. 2. Deploying the image. Once the image is built, you push it to a Docker registry, like Docker Hub or your private registry. 3. Running the container. When you need to deploy your application, you pull the image from the registry and run it, creating a container. Inside this container, your application runs in isolation with all the necessary dependencies. Docker plays a pivotal role in continuous integration/continuous deployment CI/CD pipelines. Here is how. Consistent environments. Docker ensures your application behaves the same way in development, testing, and production, reducing it works on my machine issues. Rapid scaling. Need more instances of your app? Just spin up more containers. Simplified testing. Test environments can be quickly created, destroyed, and recreated with Docker, speeding up the CI/CD process. For example, you could build your application using Jenkins, create a Docker image, and then deploy that image to a production server or Kubernetes cluster. Now, let's look at the advantages of using Docker. Platform independence. Docker runs on any system, whether it's Linux, Windows, or Mac OS. Resource efficiency. Containers share the host OS, making them much more efficient than VMs. Isolation. Each container runs in its own environment, ensuring applications don't interfere with each other. Portability. Build once, run anywhere. Going beyond the basics, here are some Docker essential services you should be familiar with. Docker networks and volumes. Docker's flexibility doesn't end with containers. It provides networking and storage options as well. Docker networks. These allow multiple containers to communicate with each other. Docker provides several networking options like bridge, host, none, and overlay, enabling containers to be connected across different servers. Docker volumes. Containers are stateless by nature, which means any data stored inside them disappears when they stop. Docker volumes allow data to persist beyond the container's lifecycle, ensuring that important information isn't lost. Next is Docker Compose. When dealing with complex applications with multiple services, for example, front-end, back-end, and database, Docker Compose becomes invaluable. It's a tool that lets you define and manage multi-container Docker applications using a single YAML file. With one command, Docker Compose up, you can start all your services, making deployment a breeze. We also have Docker Swarm. Docker Swarm is Docker's native orchestration tool, enabling you to manage and scale containers across multiple servers. It converts a group of Docker hosts into a single virtual host, making it easier to deploy applications in a cluster. Next on the list is Docker Hub, your container image repository. Docker Hub is like the GitHub of container images. It's where you can store, share, and collaborate on Docker images. Many popular applications have pre-built Docker images available on Docker Hub, saving you time and effort. Here are some common Docker commands you need to know. Docker build builds a Docker image from a Dockerfile. Docker run creates and starts a container from an image. Docker pull downloads an image from a Docker registry. Docker push uploads an image to a Docker registry. Docker ps lists running containers. Docker stop/start stops or starts a container. When it comes to real-world applications, Docker has made a significant impact across various industries. It's a go-to solution for implementing the following. Web applications. Easily containerize web apps and deploy them on any cloud provider. CI/CD pipelines. Integrate Docker with Jenkins, GitLab CI/CD, or other tools for seamless deployments. Microservices. Run each microservice in its own container, making scaling and maintenance a breeze. Machine learning. Package complex ML environments with dependencies into containers for consistent training and deployment. In conclusion, Docker has transformed the way we build, ship, and run software. It's the ultimate tool for developers and DevOps engineers, providing consistency, portability, and efficiency. Whether you're transitioning from monolithic to microservice architecture, building CI/CD pipelines, or looking to create isolated environments for testing, Docker's containerization approach offers a modern, scalable solution. With Docker in your toolkit, you're equipped to build and deploy applications faster, with fewer headaches and more flexibility. So, start your Docker journey today and experience the magic of containerization firsthand. That's all for this session. See you in the next one.